Hi rabbits, Research Turtle here. Today we are going to deconstruct the single most important fiction in our lives, money. But we aren't looking at it through the lens of an economist, we are looking at it through the lens of a physicist. We are going to explore a history of failures and a future of possibilities. The quest to anchor our economy not to the promises of bankers, but to the immutable laws of thermodynamics. Let's dive in. This is the Thermodynamic Standard. Let's start with the fundamental problem. Look at the two images before you. On the left, we have real wealth, wheat, oil, steel. These things are physical. They are subject to the second law of thermodynamics. They rot, they rust, they deplete. Entropy always wins. On the right, we have virtual wealth, money and debt. These are mathematical constructs. Thanks to compound interest, they grow infinitely and exponentially. Frederick Soddy, a Nobel laureate in chemistry, pointed this out a century ago. He saw a fatal flaw. Money that doesn't rot rules over things that do. When the math of debt outpaces the physics of the real world, the system breaks. So what happens when we try to cheat physics? This slide visualizes the modern banking system. When a central bank prints money, they are injecting liquidity, but physically they are injecting disorder. Think of inflation as the economic expression of entropy. We are moving from a state of order, where $100 buys a fixed amount of energy, to a chaotic state where value dissipates. We are trying to run a perpetual motion machine in a universe that forbids it. This isn't a new realization. In the 1930s, during the Great Depression, a group called the Technocrats proposed a radical solution. They designed the energy certificate. Instead of dollars, they wanted to use ergs or joules. Notice the details on this certificate. It has an expiration date. Just as electricity must be used or it dissipates, this money could not be hoarded. It was non-transferable. It was an attempt to force money to behave like energy. But as you can see here, the system crashed before it even took off. Why? Reductionism. The technocrats tried to reduce everything, art, love, intellectual property, to a simple measurement of joules. But human desire is complex. Furthermore, because you couldn't save or trade these certificates easily, liquidity evaporated. The economy seized up like a rusted engine. It turns out a currency that acts purely like a ration coupon destroys the incentive to innovate. Later, in the 1970s, ecologist Howard Odum tried to fix the accounting. He argued that market prices are lies because they value nature's work at zero. Sunlight, rainfall, geological time, these are free inputs. He proposed the $, a way to measure embodied energy. It wasn't a currency you could spend, but a way to see the unequal exchange where we trade low-energy fiat money for high-energy natural resources. Fast forward to the 21st century. We stop theorizing and start building. Enter Bitcoin. Bitcoin is the first working implementation of a thermodynamic ledger. Through proof of work, kinetic energy, electricity, is converted into what we call frozen truth. Unlike the central bank, you cannot print Bitcoin for free. You have to pay the energy bill. To reverse the ledger, you would have to physically unburn the energy, which is a physical impossibility. Thermodynamically, Bitcoin is an entropy engine. Mining is the process of searching through a universe of high entropy, billions of random numbers, to find a single state of low entropy, the block. We are effectively turning chaos into order, preserving value in a digital vault secured by physics. But there is a catch, and it's a big one. Critics call Bitcoin an energy sink. The energy used to mine Bitcoin is sacrificed. It's gone. It secures the network, yes, but you cannot get that electricity back to light your home. It is a one-way street. From a biophysical standpoint, is this efficient, or is it just a very expensive lock? This brings us to the bleeding edge of physics, Maxwell's demon. In information thermodynamics, there is a concept called Landauer's principle. Erasing information costs energy. But what if we don't erase it? Scientists at Lawrence Livermore Lab asked a crazy question. Can we store energy as information? This leads to the theoretical concept of the E-Stablecoin. Think of it as a reversible battery. You input 1 kilowatt-hour of electricity to mint a token. The entropy is stored as information. Later, you can destroy that token to burn it and physically retrieve the 1 kilowatt-hour of electricity. It's not just money backed by energy, it is energy. If this technology becomes real, the implications are staggering. We could generate solar power in the Sahara, mint it into tokens, send them over the internet to a snowy research station in Antarctica, and burn them for heat. No power lines, no transmission loss. Money becomes a direct claim on physics with zero friction. So, where do we stand? We are trapped in a triangle of trade-offs. Technocracy gave us physical reality but froze the economy. Bitcoin gives us security and unforgeability but at an irreversible energy cost. The E-Stablecoin promises the holy grail of reversible value, but the technology is still science fiction. Regardless of which method wins, the trend is clear. We are moving from an era of social trust, where we trust central bankers not to debase our currency, to an era of physical trust. We are beginning to trust the laws of the universe more than the laws of men. In the end, the lesson is simple. Value is not what we believe, value is what we burn. Whether it's the oil in our engines or the electricity in our mining rigs, true wealth has a thermodynamic cost. We are just finally building a money that admits it. That's it for today. Turtle out.